Alright, good day wonderful AP Chemistry students. Here's the beginning of our summer assignment, Set 1, Units of Measure and Dimensional Analysis. In a separate video, I'll be doing the second part of Set 1, which is significant figures. So let's start with this portion first, because this is really important and a skill that we must have if we're going to be successful in AP Chemistry, or any science for that matter, and that is the units of measure. This is actually a review from regular chemistry, and for some of you who have already done physics, you will have had work with each of these things as well. We have four different things that we can measure in science. That's length, volume, time, and temperature. Length is in meters or a variant, and what I mean by variant is it could be centimeters, millimeters, or kilometers. That's basically adding a prefix to the word meter to denote what type of numerical value it has. Centimeters, there's 100 of those to 1 meter, there are 1,000 millimeters to 1 meter, and there are 1,000 meters to 1 kilometer, so forth and so on. We'll get into detail about that in a bit. Volume is in liters or another variant, centiliters, milliliters, or kiloliters. Time is in seconds. There's really no variant to that. You could have milliseconds or centiseconds, but we really don't deal with that too much in chemistry. And then you have temperature, which can be in Celsius or Kelvin. We will not worry about Kelvin until we get to gas laws. That's when that comes into effect there. We will mostly be dealing with Celsius. Alrighty? No Fahrenheit, ladies and gents. I know we live in the Western world, especially in North America, where Fahrenheit is the standard, but we don't use that in science. Fahrenheit is not an SI unit, it's an imperial unit. In the land of science, we must use the international system of units. You will only find Fahrenheit in the medical field typically, or the nuclear engineering field if they still use it there. So let's go ahead and look at some unit conversions, because one of the skills that we need to have in chemistry is we need to know how to convert between units, okay? Now, we call unit conversions dimensional analysis. That's just a really fancy word for it, but all it means is just converting from one unit to another. You will have this on the Google Classroom. It will not be highlighted or have these notes that I have on it, so I would recommend that you do print this out and add these notes to it. These are all the prefixes, or all the different variants that you could have of a different unit. Okay, as you can see here, deci means 10 to the negative first power, or in other words, 10. You need 10 deci of anything to get to one of that thing. Centimeters is 10 to the negative 2, so you need 100 of whatever this unit is to get to its base unit. Milli is 10 to the negative third, which means you need 1,000 of those to get to the base unit, so forth and so on. What is the base unit? That's where I have drawn this line right here. The base unit divides the smaller prefixes from the larger prefixes. That is the 10 to the negative numbers to the 10 to the positive numbers right here. Okay, 10 to the 0 is equal to 1, so this is the base unit. These are your regular liters, meters, or anything else that could possibly use feet, yard, that can use one of those measurements that we've talked about up there. Pretty much the only thing that we will not have a prefix is units of temperature. We don't do centicelsius or millicelsius or centikelvin. I'm pretty sure you could definitely try to convert that, but it's just not useful and it's just not really practical. So base unit, this is the one of anything. These are your regular liters, your regular inches, your regular meters, so forth and so on. If you want to convert from the smaller units up to the base unit, you're going to have to use a conversion factor. And that is what this first question is right here. How many milliliters are there in 0.24 liters? So we have to look at the question and see what it's asking us to find. It wants us to find milliliters. This is what we don't know. It gave us 0.24 liters. That's where we're going to start. 0.124, I should say. So we have 0.124 liters. I'm going to abbreviate liters with a capital L. It's totally okay to do that. In fact, I would recommend it. It'll make your life much easier and the work much more neater. Whenever I'm going to do a unit conversion, we have to multiply it by a conversion factor, and conversion factors are fractions. Okay? You've seen this done when we've done stoichiometry. Now we need to ask ourselves, how many milliliters are there in a standard liter? Well, let's go back to here. I am going from liters to my milliliters. Okay. What is the conversion factor there? Well, I can see right here, this is 10 to the negative third power for milli, which means I'm going to need 1,000 of these small guys to get to the base, which is the regular liter. So my conversion factor is 1 liter is equal to 1,000 milliliters. Once you have that conversion down, it's easy sailing from there. I need to cross cancel this liter right here. So what unit do I need to put down here so that they can cross cancel by division? If you said liters, you are exactly correct. You need to have the same unit down here in order to cross cancel. You can never cross cancel two different units. They have to be the same. Which means milliliters is going to go up here, because that's the unit we're trying to get to. Now you just plug in the numbers. 1 liter, 1,000 milliliters. Liters cross cancel. All you're left with are the milliliters. Then you plug it into your calculator. 0.124 times 1,000 is equal to 124 milliliters. Never forget to tag on your unit at the end there. You are never allowed to have naked numbers in science. We must have units. Always, always, always. For those of you that wouldn't need a calculator, and technically you didn't, if you're smart enough to realize multiplying by 1,000 is the same thing as moving the decimal places over 3 places to the right, you could have totally done that. Totally allowed. Let's look at another example. How many centimeters are in 1,000 meters? Well, the question is asking us to find centimeters, so our answer needs to end in centimeters. What did it give us to begin with? It gave us 1,000 meters. That's what we're going to start with. Whenever I'm doing a conversion factor, a unit conversion, I have to multiply by conversion factor, and I'm going to abbreviate meters as small m. That's totally allowed. And now we need to figure out, well, what is the conversion factor between meters and centimeters? Let's pull up our chart here. For centimeters, it's 10 to the negative second power. So in order to get to the base, which is right here, I need 100 centimeters to get to 1 meter. Because 10 to the second power, or 10 to the negative second power, would be 0.01, or to get to the base unit you need 100 of these. So there are 100 centimeters to 1 meter. Alright, let's go ahead and determine how we need to set up the conversion factor. I need to cross cancel this meters right here. So what needs to go down there? The same exact thing, meters. And the unit we're trying to find is centimeters. We already have it defined. There's 1 meter to every 100 centimeters. Now all you need to do is plug it into your calculator, or just realize you can tag on 2 extra zeros at the end there, because 1,000 times 100 is 100,000 centimeters. For those of you that absolutely need to see it in your calculator, I'll go ahead and do it. You have 100,000. Let's do another example, but this time it's going to be a two-stepper. How many kilograms are there in 1 million milligrams, abbreviated mg? The question is asking us to find kilograms, so our answer needs to end in that. And we are given 1 million milligrams. That's where I'm going to stop. I need to multiply that by a conversion factor. What is the conversion factor? Well, let's look right here. I cannot go straight from one of the small prefixes to one of the larger prefixes. In order to get up here, you have to pass through the base first. You can think of it kind of like crossing a border into another country. You can't just go straight there. You have to first go through checks and the borderline, and then you can go into the new country. You can't just walk in. So what is the conversion factor here? I need to take milligrams to the base grams, just regular old grams first. So I need to go from milli to base. So how many milligrams are there to 1 gram? Well, milli is 1,000, so there are 1,000 milligrams is equal to 1 gram. Let's do that first. I need to cross cancel the milligrams. That'll take me to the grams. Grams is 1. Milligrams is 1,000. I'm not going to solve just yet because I am not at kilograms. I still have to take this one step further. I need another conversion factor. I'm now at the base grams, so now I need to go to the kilograms. What is the conversion factor between the base gram and kilogram? There are 1,000 grams in 1 kilogram. You see, this time the base is not 1 because it is the smaller unit. Kilogram is bigger, so it can't be 1. I'm sorry, kilogram is bigger, so it has to be 1. The base has to have the large number this time. So in other words, 1 kilogram is equal to 1,000 grams. These milligrams cancelled. I need gram down here to cross cancel that gram, and then I'll have kilogram up here. Alright. 1 kilogram, then 1,000 grams. And now all you have to do is plug it into your calculator. You had 1 million divided by 1,000 equals that, divided by another 1,000. That is equal to 1. Kilogram. So in other words, in 1 kilogram, there are 1 million milligrams. Go ahead and try out those practice problems I left for you, and I might add some more a little on later in the summer so that you can get some extra practice. That'll end it for this video here. We did it in a record time. We only have 15 minutes, 15 seconds to spare. If you have any questions, feel free to post them on the Google Classroom or on the Remind. Alright guys, good luck.